right, guys, this is Mrs. Lyons. I hope you're having a great day. Before we get into the notes packet, I just wanted to show you an official definition of stoichiometry, which is what we're starting to talk about. So stoichiometry specifically refers to, as you can see here, the determination of the proportions in which elements or compounds react with one another. All right, so in other words, when two elements or an element and a compound react, they have to react in the right proportions so that there's the right number of atoms interacting. So stoichiometry is what allows us to accomplish that. So I always say it's the math of chemistry. Okay, so if we look just for our purposes, stoichiometry is finding the amounts of substances needed or produced during a chemical reaction. All right. And the way that this works is if you want a specific amount of product, you can calculate how much reactant you will need. Or if you know that you have a certain amount of one reactant, you can figure out how much of the second reactant you need. Okay. So that is stoichiometry. And then what the other thing we need to know about stoichiometry is that stoichiometry uses, and this is why we have been really balancing our chemical equations and stressing that, stoichiometry uses a chemical reaction, a chemical equation, and we should add a balanced chemical reaction or chemical equation to find a mole ratio. Okay, this ratio is then used as a conversion factor to convert between different compounds. Okay, so we used conversion factors when we were talking about stoichiometry. Okay, so what this means for us is chemical equations, as we said in class, work like recipes. Okay, if you're making a grilled cheese sandwich, you could, and this is just a little bit different than in your notes. So this is just another example. Oops, and let me slide this up so you can see it. If you're making a grilled cheese sandwich, okay, the recipe for a grilled cheese sandwich is 2 bread, 1 cheese, 1 equals or makes 1 grilled cheese. Okay, the coefficients give us the mole ratio. Okay, so in this case, in this recipe, these are our coefficients. Okay, they give us what we call a mole ratio. And again, this is different than is in your packet. It's just an additional example. Okay, we used the s'mores example in class. So if we wanted a ratio of bread to grilled cheese, we would say for every 2 slices of bread, we make 1 grilled cheese. And we can actually write this as a real ratio, so 2:1. Or we could say for every 1 slice of cheese, we can make 1 grilled cheese sandwich. So the ratio there is a 1-to-1 ratio. Okay. So here's an example from tropical smoothie. Okay, so let's say that tropical smoothie uses 3 cups of strawberries, 1 banana, 2 cups of mango to make 1 smoothie. If we wanted a mole ratio relating mangoes to smoothies, we would say for every 2 cups of mango, we make 1 smoothie. Whoops. Okay. If we wanted to look strawberries to mangoes, we would say for every 2 cups of strawberries, we need 2 cups of mangoes. Oh, sorry, my bad. Every 3 cups of strawberries, we need 2 cups of mangoes. Okay. So those are that would be our mole ratio if we were talking about making smoothies. So we are not talking about making smoothies. We are talking about chemical reactions. Okay. So we have to talk in terms of chemical compounds. Okay. So let me just grab a piece of paper and I'm gonna balance this equation. I'm gonna actually walk you through the steps of balancing this, and I'm gonna walk you through 2 ways because I know there are some of you who are still kind of struggling. Okay, and that's okay. Practice, 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 and you will get it. I promise. If you practice enough. All right. So we're reacting nitrogen plus hydrogen to produce NH3. Okay, so I'm going to do the first way where we just literally write things out. So if I look here, I have 2 nitrogen, right? Over here, I only have 1. Remember, if there's no subscript, it's as though there's a 1. That's it, just we don't have to write it. So 2 nitrogen here, 1 over here. I need a second nitrogen, but I can't just add a nitrogen. I have to add the whole compound. So I have to add NH3. Okay. So now I have 1, 2 nitrogens on each side. I also have 3 plus 3. I have 6 hydrogens. Over here I have 2. So if I do 1 hydrogen, that gives me 4. A second H2, that gives me 6. So now my equation is balanced, okay? And that required 1 molecule of N2, 3 molecules of H2, and 2 molecules of NH3. Okay, so that's one way to balance it. Okay, I said I was going to show you a couple of ways, and I'm going to do that because everybody does this differently. Everybody's brain works a little bit differently, and you will find a way that clicks with you. And what works for you may not work for your best friend. You may go about this completely differently, and that's okay. Because if you find what works with you and you practice that way, when you come to a test or a quiz, you'll be okay. You'll be able to get through it in the time allowed. All right. So this one I'm going to do kind of the tallying method, okay, where I put in the middle, I say I've got nitrogen and hydrogen. And then I look at, remember this arrow is the dividing line. So I look at how many nitrogen I have over here. I have 2. How many hydrogen? I have 2. And then on the product side, I have 1 nitrogen and 3 hydrogen. Okay, so once again, as we saw in the other example, doing it the other way, it's the same process. I have 2 nitrogen here and 1 here. So I need to put a coefficient here. If I put a 2 here, that gives me 2 nitrogen. It also changes my hydrogen because 2 times 3 is 6. So I have 6 hydrogen. Okay. So my nitrogen is balanced. My hydrogen is not. I've only got 2 here and I need 6. So if I put a coefficient of 3, 3 times 2 is 6. Now my equation is balanced. Okay. One more way, because some of you are already telling me you can do this, and this is absolutely fine. Okay. And this is one time in chemistry where we say, I don't need to see your work. If you can do this in your head, that's awesome. I'm not going to be like, oh no, you have to write it down. Just do it. So like, for example, some of you can already do this. You're like, okay, I've got 2 nitrogen here. So I need to put a 2 here. That gives me 2 times 3 is 6 hydrogen. So if I put a 3 here, it's balanced. Okay, so some of you will be able to, do that quicker way. But whatever way you have to go about it, you need to figure that out because we can't really get to the stoichiometry until we balance. All right. So mole ratio. We said the mole ratio is based on the coefficients. Okay, so the mole ratio of nitrogen to NH3. I have 1 N2. I have 2 NH3. Here, if I have 2 moles of NH3, I need 3 moles of H2. So literally, you're just taking the coefficients here. Okay, so the next thing that we're going to talk about is this mole to mole conversion. Okay, so we're going to show how to use these in calculations. Okay, so there's some steps, and we always go through the steps first, and then we show you how these steps work. Okay, you're going to use the mole ratios to convert moles of one compound into moles of another compound. All right, so the steps. The first thing you always have to do, you have to balance your chemical equation. All right. The next step, you need to write down what you are looking for. And then you determine the mole ratio needed for the problem. All right. You're going to set up the conversion so all units cancel out. All right. And then you're going to solve. And I spelled cancel wrong. Oh my gosh. Okay. And then you're going to solve. All right. So let's look at some examples. So let's see. Here we have, so we've got the same equation we just had. So I'm going to transfer my coefficients over here. If an engineer has 50.50 moles of H2, how many moles of NH3 are produced? Okay, so this is another one of those. Our given is the number, so 50.50 moles of H2. And we're looking for, our unknown is moles of NH3. All right, 50 moles of H2. Now, remember when we were doing the other calculations like molar mass, using molar mass, moles to grams, I said I wanted you to write down the element or compound, but if you didn't, I wasn't really hard about it. In these calculations, you really need to. And the reason is because this step of our conversion uses the mole ratio. Okay. And in this case, I'm going from hydrogen to ammonia, NH3. So my mole ratio is 3 moles of H2 makes 2 moles of NH3. Okay, so it's really important to know which substance. So hydrogen is going to go on the bottom. So 2 moles of hydrogen and, 3 moles. 3 moles of hydrogen and 2 moles of NH3. Okay, the purpose is always that our units are going to cancel out. Okay, if I calculate this, I'm going to do 50.50 times the top, so times 2, divided by the bottom, divided by 3. And you can do it all in one thing in your calculator. And I get 33.6. I'm going to round to 33.67. My units remaining are moles of NH3. Okay, put a box around that. Okay. All right. Question number 2, example number 2. If a scientist wants to make 12.5 moles of NH3, how many moles of N2 are needed? Okay, so our given is 1250 moles of NH3, and our unknown is moles of N2. And we might as well write our mole ratio. Okay, so our mole ratio would be 2 moles of NH3 produces or is produced by 1 mole of N2. Okay, so let's set this problem up. All right, 12.5 moles of NH3, always over 1. No unit, just 1. Okay. Then my conversion, moles of NH3 is going to go on the bottom, so 2 moles NH3. And then 1 mole of N2 goes on top. All right. So now if I take my handy dandy calculator, I would do 12.5. I don't need to times by 1 because we know 12.5 times 1 is 1. And then I'm going to divide by 2. Sorry, my puppies are in the back and there are people walking outside. So I get 6.25. If these units cancel, I end up with moles of N2 as my final answer. All right, 2 more that we're going to try together, and then I will let you try some on your own. All right. Oh, we have to balance this. See, that's why balancing is so important, because everything we do with stoichiometry has to be balanced. All right. So I'm going to have you stop the video and balance this, and then come back, and I will have it balanced. Okay. So stop. All right. Are you back? So let's see. This should be 3, 3, 2, 2. All right. If you didn't get that, ask. Okay, raise your hand, ask. If you're in class, if you're at home recording this because you didn't do it at school or you weren't at school and you're not sure how I got those coefficients, ask. Okay, so here we go. A scientist is trying to produce 2.8 moles of C2S. How many moles of Fe2S3 are needed? So our given is 2.8 moles of CS2, cesium sulfide. Our unknown is moles of Fe2S3. All right. So if I want to look at my mole ratio is going to be 3 moles of CS2S to from 2 moles of Fe2S3. So our mole ratio is 3 moles of cesium sulfide is produced by using 2 moles of iron 3 sulfide. So let's set this up. We put our given 2.8 moles of CS2S over 1. And then our mole ratio is 3 moles of CS2S and 2 moles Fe2S3. All right, so let's calculate 2.8 times the top times 2 divided by the bottom divided by 3, and I get 1.87 moles of Fe2S3. And notice I'm putting all my numbers with 2 places after the decimal. That's what I would like to see. Okay. All right. Second problem. If a chemical engineer wants to make 5.48 moles of iron 3 oxide, Fe2O3, how many moles of iron 2 sulfide are needed? Okay, so our given is moles. We have 5.48 moles of Fe2O3. And our unknown, what we're looking for, is moles of Fe2S3. All right. And our mole ratio is from our balanced chemical equation. So moles of Fe2O3, 2 to 2. So our ratio is 2 to 2. Okay. Now, you could simplify that, but I'm going to ask you to not simplify it. That way I know that you know where the numbers are coming from. Okay. So, because I still want you to write this out. So 5.48 moles of Fe2O3 over 1 is going to be, so moles of Fe2O3 goes on the bottom. Where did it go? Fe2O3, so 2 moles Fe2O3. And on the top, we have 2 moles of Fe2S3. Okay. So we know those 2's cancel out. We get the same answer we started with. So 5.48 moles of Fe2S3. All right. So that is how we use stoichiometry to determine mole ratios. All right. So I hope that made sense. I hope that helped. And I will see you guys in class.